Good evening, all of you. Today's topic of discussion is theorem of parallel axis. Here, the word comes axis. It is not a one axis. The plural of axis is, we can say that, axis. If more than one axis is present over there, then we can call it as an axis. Now, what exactly we wanted to use this kind of theorem is? For example, say let's take a object like a disk. Let's say if this is a, we can say that disk, and we are going to rotate this particular object along this axis. We are going to rotate this object along this axis. This is nothing but a, we can say that, axis of rotation. Axis of rotation. As it is the axis of rotation and it is, say, supposed to passes through a center of mass. This is passes through center of mass, right? And as this axis is passes through center of mass, then this object will offer certain, it will offer, what it will offer certain amount of certain amount of certain amount of opposition, a certain amount of resistance, and that opposition we can call it as a moment of inertia. We can supposed to call that particular opposition is nothing but a moment of inertia. So while rotating this body about this axis, this object offers a opposition to us or to any object which is applying force on this particular object. That opposition is called as a moment of inertia. So moment of inertia about this axis I'm going to take, that is equals to IC. So what moment of inertia about the, we can say that, about that axis? So that is nothing but a, we can say that we are going to denote it by letter C. C is what? The center of mass. So after, when this axis is passes through this particular center of mass, then moment of inertia about this axis is denoted by letter IC. But if we are aware of IC, if we can calculate IC and we wanted to find out the moment of inertia about another axis, we wanted to find out moment of inertia about another axis. That axis, say, we can take any random axis which is parallel to the IC. So that time, if we wanted to find out the moment of inertia about this axis, and that I'm going to denote by letter I0 or IO, any ordinary axis. For that's why I just denoted over here O. So what IO represents? IO represents the moment of inertia about the any ordinary axis which is parallel to the, we can say that, this particular axis which is passes through center of mass. So here these two axes are parallel. So that's the reason why here we can apply our theorem of parallel axis. So that's the reason why for such a kind of cases we can use theorem of parallel axis. Let's take another example. Say take a rod. Take a rod, and the center of mass is situated over here of this particular rod, and we are going to take a axis of rotation that passes through the, we can say that, center of mass, right? And moment of inertia about this particular center of mass I'm going to denote by letter, that is equals to IC. Moment of inertia, C for center of mass, right? Now if I take another axis of rotation that passes through end, we can take another axis of rotation that may passes through the half of the end. So in such a cases, say this is axis XX, say this is axis, we can say that YY, and we wanted to calculate the moment of inertia of this particular, we can say that, object about this axis. So that I'm going to denote it by IXX, or moment of inertia about this particular axis YY. That moment of inertia I'm going to denote it by letter IYY. So in such a cases, whenever we wanted to find out such a moment of inertia and we knew the formula for the IC, in that particular case we can calculate such a moment of inertia. We can calculate such a moment of inertia if we are aware of a theorem of parallel axis. So here we have such a cases where we can apply theorem of, we can say that, parallel axis. We will write the statement of theorem of parallel axis. Its statement we're going to write down. So what is the statement of that particular parallel axis? It states that it states that the moment of inertia, it states that the inertia, moment of inertia about moment of inertia about any axis. The word any axis is very important. The moment of inertia about any axis, moment of inertia about any axis is equal to commonly upon, it states that what we said over here, it states that moment of inertia about any axis is equal to the sum of the sum of its moment of inertia, moment of moment of inertia about a parallel axis, about parallel about a parallel axis passing through its center of mass, passing through its center of mass, and product of its mass, and square of the perpendicular distance, and square of perpendicular distance between two axes. So this is nothing but a statement of that particular theorem. So what exactly this theorem states? What exactly this theorem mean? Let's take any rigid body. Say we supposed to have any rigid body, right? We supposed to have any rigid body, and we have a point C. This is the center of mass, and we are going to consider that the axis which passes through the center of mass, one axis is passes through center of mass, and the moment of inertia about this axis, which is we knew, that is nothing but IC. And we wanted to calculate moment of inertia about any axis, any ordinary axis. Say there is a one point, any ordinary point. Say this point is O, and we are going to pass the axis of rotation through this particular point, and that these two axes. Say this is axis X, this is axis Y, and here we have a two axes, right? Now these two axes are parallel to each other, and we wanted to calculate the moment of inertia about this axis, and that I am going to denote by letter I-O. So in a statement, what is given over there? Moment of inertia about any axis is equal to, means moment of inertia about any axis is equals to, moment of inertia about any axis is equals to the sum of, means it is a addition of, it is a sum of its moment of inertia about a parallel axis. So parallel axis passes through center of mass and the product of mass and the perpendicular distance square. If the distance between these two parallel axes is equal to h, then the statement its mathematical formula is like this. So what this particular formula, that particular stats that I'm explaining, something like this. We have such kind of diagram. We can say that triangle OPD, right? We can use a Pythagoras theorem in this particular triangle. So if you wanted to use a Pythagoras, this is PD is perpendicular to, we can say that OD, right? So OD is and PD, they are perpendicular to each other. So we what kind of shape here for, that is a triangle. So by Pythagoras theorem we can use that is in this particular triangle. Pythagoras theorem, that is OP square will be is equals to, we can say that OP square will be is equals to OD square plus PD square. So this is the first triangle. Second triangle we can have What is the second triangle? That is CPD. So in a, that is smaller one, smaller triangle, that is a CPD. In a triangle CPD, again we can use a Pythagoras theorem. By using a Pythagoras theorem, CP square will be is equals to CD square plus PD square plus PD square. From this equation, I'm going to write down this particular term again. What that term is, OP square will be is equals to OD square plus PD square, right? So OP square I'm writing again. Now instead of OD is made up of two things. It is made up of OC and CD. So instead of OD, I'm going to write down OC plus CD whole bracket square in this particular term plus PD square. And in a mathematics, we can have a plus b bracket square, a square plus twice ab plus b square. So that will be is equals to OC will be is equals to OC square plus twice O into C into CD twice A into B plus CD square plus PD square, right? So from this equation, we can say that from the second smaller triangle, CD square plus PD square is equals to CP square. So CD square plus PD square, we can write down CP square. So this equation will become OP square will be is equals to OC square plus twice of OC into CD plus instead of CD square plus PD square, instead of CD square plus PD square, I can write down CP square. Right, so we got a new statement, new, well, we can say that. So now we can put the values of, so OP is equals to R, OC is equals to H, CD is equals to X, CP is equals to R0 in this particular equation. So by placing, what exactly you will get? What is OP? OP is R. So I'm going to write down that term again, R square. What is OC? OC is nothing but H. It's square. Plus twice of OC is H. Into CD is X. Plus CP is R0. That is R0 square. So we got another statement. So R square will be is equals to H square plus twice H into X plus R0 square. So I'm going to write down that term again. Right, so what that term is, we can say that that term is equals to R square plus H square plus twice of H into X plus, we can say that what it is, R0 square. Now multiply on both side by delta M. Why we wanted to multiply, that I'll explain in the next term. Multiply on both side, multiply on both side by delta M. You can multiply on both side by, we can say that, delta M. So by multiplying here, what will happen? Delta M into R square.
Sir,
Huh?
X square आयला.
So multiply on both side by delta M. What you will have? So will be equals to delta M into whole that particular bracket. I'm going to make this bracket over here. So the bracket will be within a bracket. What will be over there? H square plus twice of HX plus R0 square. So by multiplying delta M inside, what exactly term? Delta M into R square. Delta M R square will be is equal to delta M into H square. Delta M H square plus that delta M will get multiplied inside also, twice of delta M into twice Hx, twice H I am writing again, delta M I am going to write down, and then X plus delta M into R0 square, delta M R0 square. So in this term we have a different kind of terms. Which are the terms? So this is the first term, delta M into R square, that is important for us, delta M into H square and delta M into R0 square. So that is very, very important term. So what that term exactly we have? Integration of delta M into R square is equals to I0. Integration of delta M into R0 square is equals to IC. Integration of this particular, we can say that H square will come outside, delta m will be is equals to m into h square. So this is the term very important, and integration of x delta m into twice h will be is equals to 0. So these four terms we need to apply over here. Okay, we need to place over here. So what exactly it means? So the integration of delta m into r square equal to I0, mass into perpendicular distance square equal to moment of inertia. Mass into perpendicular distance square equal to moment of inertia. And addition, integration means addition of all the masses, and addition of all the masses, all the point masses of that body is equals to capital M, and that S square will be remain as it is. And integration of x delta m, that is moment of inertia about an axis that passes through center of mass, sorry, moment of inertia of a body about a center of mass equal to 0. This term always 0. And if you place the value over here, so integration of delta m into r square, that will be equals to I0. So that term will become I0 will be is equals to delta m into s square. Delta m into s square will be is equals to mh square plus this term instead of this term will be equal to 0 plus delta m into r0 square. Integration of delta m into r0 square equal to IC. So the final term here we got, that is equals to I0 will be is equals to IC. I'm writing again first and then this mh square. So this was the statement that we wrote first. This was a statement that we